you cross over from algebra to calculus. All right? It is not something that you're going to have to do every single question in calculus. You're not going to have to. But you have to think in terms of the limit to understand the derivative and the antiderivative in calculus. Does everybody understand what I'm talking about?
Mm-hmm.
So, I'm not going to spend a whole unit going over something that's nothing but conceptual. It would be like me spending a whole unit in algebra on the distributive law. Once you learn to distribute a 2 with an x and a 2, there's no need for me to spend a whole unit on that one thing. So I'm not going to spend a whole unit on the limit theory. Now, what is the limit theory? Well, I'm going to go to the whiteboard, and I'm just going to pull up a limit, or I'm just going to write a limit. Up until now, you have learned about functions, and f of x is equal to x plus 2. And you graph it the algebraic way, you graph it, and plus 2 is your y-intercept, and you know that there's a line going like that. Everybody with me? And if I ask you what is f of 2, you tell me that f of 2 is what? 4. And if I asked you, that's f of 2, that means x is equal to 2. That means that this point is equal to what? 4. If I asked you what f of 5 is, you tell me that f of 5 is equal to what? 7. There's 5. This thing goes crazy when I write in dots. And that's 7. Now I want you to make sure you understand that f of 2 and f of 5 means that I am asking you for a point. Does everybody understand that? The limit theory basically says not that you're on that point, but you are what to that point? The key word when you're talking about the limit theory is you are not on that point, you are what?
You're close to it.
I just wrote it on the board, you should see it. Not that you're on that point, but you are what?
You're approaching the point.
You're approaching. Thank you. I appreciate that, Ms. Sterling. It's so nice to have somebody not being a tit on a bull. Thank you very much. All right.
I didn't do a thing.
Who was that? I'm sorry, Ms. Sterling.
That was
I thought
me.
That was you. Who was that said that?
Grant. Hello. Hi.
Oh, okay. Thank you, Mr. Hitt. All right. Thank you for interacting. I appreciate that.
You're welcome.
Maybe some other people can take notes and, say something.
Why you gotta at me?
What?
Why you gotta at me?
I'm sorry. I'm just trying to make you quit because that's what I'm supposed to do. All right. Limit theory means that you're approaching. So what I'm saying is you're going to have to come away from this. All right. The algebra that you learned. And when you see an f of 2 and an f of 5, you say, okay, I'm going to plug that in, and that's what I'm going to get. I'm going to be on this point. Versus approaching a point. Now, well, of course, I know some of y'all walk on water and some of y'all invented the limit theory, but there's some of you that always gets confused with the limit theory. All right? There's some of you that really suck at the limit theory. All right? So that's what I'm trying to differentiate between what you learned all the way up until this point and what you're going to learn in this little section that we're going to go over, mainly 2.3, 2.1 and 2.3. And apply 2.1 and 2.3 to chapter 3, which gives you algebra plus limit is equal to calculus. So, when you approach something, it's going to be written like this. Limit, and I'm going to use this point right here. I'm going to use 3. Limit as x approaches 3 of x plus 2. Now, are these two the same? That's a yes or no question. Not even close. One is an elephant, the other one is a tiger. And you have to differentiate that. You have to say, okay, this is not the same type question. When I put that limit out there, when I put this there, it changes it dramatically. And this is saying that when I approach, since I don't have a plus or a negative here, this is just saying that I'm approaching from both sides. As I approach 3 from the left, and I approach 3 from the right, what am I approaching on this function right here? And you, of course, would say 5, because that point right here is going to be what? 5. As I approach this 3 from the left and the right, on my function, I'm approaching what y value? 5.
I was totally thinking about derivative. Sorry.
That's fine. That's fine. Don't worry about it. Okay, so the red is a different concept. This is technically called the Squeeze Theorem. And you might want to write that down. You may see it sometime. I don't know. Squeeze Theorem. The Squeeze Theorem basically says this right here. Let me get rid of this right quick. And that's the Squeeze Theorem. And they put the lambdas and they put all that. It doesn't matter. If I approach from this direction, from the left or the right, and that's what I just drew. If I approach 2 from the left, then I'm approaching 1.5 from the left, or this area right here. If I approach 2 from the right, then I'm approaching on the function y is equal to 1.5. And the biggest thing that you have to realize is you're talking about approaching. Well, Hubert, how close are we? We got to think out of the box. You're getting as close to 2 as the width of a hair. Okay? Or 5/100ths the width of a hair. You've got to think out of the box here. You can't be Billy Bob Redneck and go, well, that's just 2 then. No, you can't do that. If you go into calculus with thinking that 2 is 2 and not a width hair off of 2, then you're going to have a hard time. All right, so the Squeeze Theorem says that if I approach 2 from the right, and it's going to be a 2, limit as 2, and it'll have a plus there. And if I approach 2 from the left, and that'll be a 2 with a negative to the right, like that, then my limit of this function is 1.5. So when you're given a limit, usually, normally, when you're given a limit, well, what happened to it? Hold on a minute. There we go. When you're approaching a limit and they give you this thing right here, basically what you're going to be given as an answer is the answer as x approaches a number, what is y what? Approaching. Most of your questions, okay, most of your questions in chapter 2 will revolve around, I'm giving you this, and I'm giving you this. You tell me what it's approaching as far as y. That's the difference between the algebra that you grew up with in K through 12 or K through 13, which is Algebra 1, 101, 102, whatever you want to call it, 110, okay? That's the difference between that and the limit theory. And the limit theory basically says if you take a half a step, if you take a 4-foot step toward the wall, and then you take half of that step, that's 2 foot, and then you take half of that step, that's 1 foot, and then you take a half of it, and the half of it, you never will reach the wall, but you will get right up to it within a thousandth of a width of a hair. And that's what you have to be thinking of. Now, I'm going to go ahead and show you a couple of problems and it's not going to be that difficult, but let me tell you something. When you go into calculus 1, 2, and 3, there's going to be times that you're going to be given a simple concept, and you're going to walk out of the classroom lobotomized. Have you ever been in a math or a science class or a class where the teacher taught an easy concept and you walked out not even knowing which way is up? Okay? This is where a lot of students, they suck at the algebra. They're not very good at the algebra. And then they go into this limit process and they spend a whole 2 or 3 weeks on the limit. And the students, by the time they get through with the review unit and they get through with the limit unit, they're lobotomized and they don't know how to do calculus. That's what happens. So, I'm going to go clear this out. And of course, they give you evaluating the limits right here. Here's an example. Now, if I was to ask you, what is f of 2? If I ask you what is f of 2, and I'm going to write it in green, okay? And this is a graphical representation. This is what you're going to see in 2.1. So write this down in your notes. This is what you're going to see in 2.1. So I take my green, I'm going to give you a graphical representation, several graphical representations out of 2.1, and I'm going to give you a lot of algebraic representations out of 2.3. And then I'll decide what I'm going to do after that. But that's the only two I'm really interested in. Okay, so we're going to take the green pen, and I want you to tell me what f of 2 is. What is f of 2? Well, it should be 2. 2. And if I was to ask you what f of 3 is, well, not f of 3, f of 2.5. Well, you would go 2.5 is right there. That's going to be about 2.5 there, or give or take a good bit. And then I say, well, what about f of 3?
Why is it plus or minus?
Huh? Because I can't tell. I can't tell. I don't have a straight edge, and I can't tell. It looks like 2.5, but I don't have a straight edge to actually do it. Okay, I'm just eyeballing it. That's why.
Well, the function does say X.
Oh, okay.
X.
Okay, I didn't
So
see
you know
that.
it's one.
Okay, so it would be,
Yeah.
thank you. So it would be, all right, my bad. There we go. All right, so I'm doing 2 or 3 things at one time here. So when I get to the f of 3 is going to be equal to 3 because I got a dot here. But f of 3 as a limit is approaching, I'm sorry, not this dot right here, this is 3.
The limit of it.
Yeah, f of 3 is equal to 3. It's approaching. But that's only from the what?
From the left.
That's only from the left. Why? Because if I approach, here's x is equal to 3. As I'm approaching from the left, what is this one approaching? 3. But if I say what's approaching from the right, what is f of x as limit? F of x as limit is approaching 4. Is it 4? 3. 3. 3 from the right. As I'm approaching 3 from the right, I'm not on this green line anymore. I'm on what? I'm on the blue line. And now it's approaching 4. So when you're talking about the blue line, if I give you f of 4, you're going to say, okay, 4 minus 4, that's equal to 0. 0 squared is 0 plus 5. So if I ask you what f of 4 is, you're going to tell me it's equal to 5. That's the algebraic way. Okay? But if I ask you what f of x is equal to blah, 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 and I say limit as x approaches 3 from the right, you're going to say that it's approaching what? 4. It's approaching 4. Now, of course, you don't have to say approaching 4. You just have to put 4 because the question is a limit question. This is an algebraic solution question. This is a limit question. As I told you before, it's different. So when you put a 4 right here, you may just put the number 4 right here, but it means you are what? Approaching 4. Whereas when you approach 3 from the left, you're approaching 2, and it's going to be on the green line. So again, we're not talking about major rocket science here. We're talking about a different way of thinking. Just like I told you, if you take 4 foot toward the wall, and then you take 2 foot, and then you take 1 foot, half a foot, 1/4 of a foot, 1/8 of a foot, will you ever reach the wall? No. But you will get up what? Right beside of it. You will approach the wall. And it's very, very critical that you understand that. All right, let's go to, I'm going to jump over to a couple of questions in 2.3. Now, I do not want you to do any homework right now because you got plenty to do with your test and your homework. When's the homework due?
Tonight at midnight.
Okay, so you got plenty to do. I'm going to go back here. I'm just going to pull up chapter contents 2.3 because that's 80. If I gave you a chapter 2 test, 80% of the test will come from 2.3. So I'm just letting you know. 2.3 is a very important section. Study plan. I hope they don't ask a bunch of stupid questions in this class. I want to find. That's a simple question. Just think. As it approaches 6, what's 3 times 6?
18.
18 minus 5 is?
13.
So you are approaching 13. Now I know it says equal, And I know that some of you may say, well, it says equal. But this is not an algebraic. This is a limit. So when you put 13 right here, you're not saying the solution is 13. You are saying that you are approaching 13. And you would put that in there, and then you'd feel good about yourself. Okay? I can't emphasize the word approaching enough. That's not what I want to show you. What I want to show you is when you have to bear with the fractions. That ain't the one I want. But we can do this one. What about that one? Well, plug and chug. Plug and chug what? You plug and chug to -3 because you are approaching x is equal to -3. So what is happening when you get to -3 on the x-axis? Well, plug and chug. And this is not the one I wanted to show you, but it's a good warm-up. So -3 parentheses squared plus 5 times parentheses minus 12 over 8 times parentheses minus 3. Now, of course, I've put parentheses in there. I've only got several degrees. I think I've got 4, 3.5. But, you know, y'all may not need it because some of y'all have how many degrees? But I use it because sometimes you're given a fraction or a decimal or a negative, and sometimes it helps for those that didn't invent limit theory. Okay, so I'm going to plug in that -3. I'm plug it in here, plug it in there. -3 squared is 9. 9 times 3 is 27. -3 times 5 is what? -15. Minus 12 over -24 minus 3. Now it's just nothing but plain mathematics. 27 minus 15 is what?
12.
Huh?
12.
12. 12 minus 12 is 0 over any negative number is equal to what? So what am I approaching as x is approaching -3? What is your y approaching? Okay, we're not going to say the word. We're not going to say what we got for an answer. We're just going to be quiet.
0.
Thank you. Boy, I ain't kidding you. These millennials. Oh my God.
I thought you crossed through the 0, and I was having a brain fart moment. Thought you were
No,
saying
that's just the way some people write zeros, especially if you're in binary and computer technology and computer. You write it with a 0. I mean, with a yeah. Okay, so that's that, and you feel good about yourself.
You didn't have to write your zeros like that when you were military?
Yeah.
Oh, okay.
Well, yeah, I just meant that some, especially in college,
Yeah.
a lot of your computer technology, computer science, computer engineering,
Yeah.
in the binary system, you need to write that as a 0 with a
Yeah.
slash through it. All right. And you were in the Navy. Y'all deal with clocks. We can't. Marines can't read clocks. So y'all the smart guys. All right. So that's how you do that one. And again, most of you go, oh, that's not a problem. Where do we get into the problems? It's when you get into one like that. Let's see. No. Let me find one. Just give me a second. There we go. And then the walls come crumbling down. Because why? Somebody tell me why. Somebody that knows limits, tell me why this one poses a problem.
Because you have a 0 in the denominator. So
You can't divide by 0. So all you have to do is just cross it out and go on to the next problem, right? One rule of calculus. This is Hubie's rule of calculus. And I tell this to all my calculus students. If it is real easy, chances are it's wrong. Okay? When you say to yourself, oh, well, if I plug in a 3, I get undefined, so I'm just going to put undefined. Calculus is not that easy. If you do a problem and it comes out to be that easy, chances are you're missing what? You're missing something. So, when in doubt, factor it out. When in doubt, factor it out. So, I got limit as x approaches 3 of x squared minus 9 over x minus 3. And which of those do you recognize something? The x squared minus 9 is shortcut number 3, which will give you x plus 3 times what? X minus 3 over x minus 3. And the x minus 3 cancels. And you're left with the limit as x approaches 3 of x plus 3, which gives us, what is y approaching?
6.
6. Now that's what y is approaching. What did we learn back in algebra about this x cannot equal 3? What does that tell us? That's our vertical what? Asymptote. And a vertical asymptote in this section is going to be a what circle? Oh, open circle. So you're going to have an open circle at x is equal to 3. So you're going to have some kind of function. I don't know what the function looks like, but it's going to be some kind of function, blah, 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 blah. And 1, 2, 3, you're going to have an open circle at 3. And at 3 up here somewhere, it's going to be approaching 6. And I don't have an example. You just have to graph it and see. But the whole point is, when you start with the initial, yes, plug in, set equal, that is a open circle at 3. And then somewhere above it, you're going to see, or below it, you're going to see that as you're also approaching 3, you're going to be closing in on 6 as a y. So in this case, you should put.
Would that not be like a parabola open block?
It could be. I don't know. I don't know what is. Yeah. Pretty much. That's why you have to actually graph it. I'm going to put a 3. That's not my point right now. We're going to get to the graphing in just a minute. What? Oh, 6. It's supposed to be 6. Sorry. Okay. Didn't like that either. Okay. Oh, they want you to graph it. They want you to x. What is it? X plus 3. X plus 3. I'm getting there, people. Hold on. I'm about ready to quit. X plus 3. There. There we go. And then they may ask you to finish it out. 6. Surprised they're not asking you for the vertical asymptote. Nope. And again, you're going to run into something like that. You're also going to run into complex rationals. Let's see if I can find a complex rational. That's a reverse FOIL. So all that factoring, that's where it comes in. Also, when you have a radical in the denominator, you got to rationalize the denominator. That's reverse FOIL. Same thing here. You need to multiply by negative. That was rough. That would be a negative.
Still pretty.
Yeah, you can still do it. I'm trying to find the one. X minus b. That one's going to be x minus b. You can factor out x. Right there is x minus b to be x minus b to the 19th. One of those will cancel. I'm not worried about that one. I'm trying to find one that you're going to see. God, where did these. There we go. All right, what do we do here? Quit? Erase the H. Erase the H on the bottom. Is that what you do? Get a common denominator on the top, and then divide by a fraction, which you multiply by the reciprocal. So this is where your algebra comes in. Remember me telling you if you suck at algebra, you're going to suck at limits? Well, this is why. Here we got limit as h approaches 0. 1 over 5 plus h minus 1 over 5 over h. Now, a while ago, you had a shortcut or a trinomial, and the rule was, when in doubt, factor it out, right? Here, you're going to have to add that. Well, you got two fractions on top. Make it one fraction. So we've got to get a common denominator. Common denominator is 5 plus h times 5. So I'm going to get a common denominator. I'm just going to work with the top right now. And that's going to be 5 times 5 plus h. And how many times will 5 plus h go into 5 times 5 plus h? 5 times, Hubert. That's right, class. 5 times 5 times 1 is 5. How many times will 5 go into 5 times 5 plus h? 5 plus h times. But there's a negative up here, so that's going to be minus 1 times 5 plus h times. And that's going to give us 5 minus 5 minus h over 5 times 5 plus h. And the 5's cancel. And that leaves you with negative h over 5 times 5 plus h. Now I'm going to go down here, and I'm going to rewrite it. Limit as h approaches 0 of, and I'm going to rewrite my new numerator, negative h over 5 times 5 plus h divided by h over 1. Now, why did I change that to h over 1? Because if I divide a fraction by a fraction, I have to multiply by the what? Reciprocal. So now I'm going to take that 1 over h. Oh my gosh, look at there. What happens to the h's? They cancel, Hubert. And that's left. Your final answer is limit as x approaches 0 of negative 1 over 5 times 5 plus h. Now we can plug in 0. So what happens when we plug in 0? You get negative 1 over 25, don't you? So limit as x approaches 0, y is going to approach, y is going to approach negative 1 over 25. Say again?
Your h.
I didn't hear what you said.
Your limit, your x is still your h, so your limit is h, still approaching 0.
Oh, yeah, whatever. Yeah, thank you. That's one of my weaknesses. 99% of the time it's x, but I'm sorry. Yeah. As you can see, the substitution is not the problem, is it? I just plugged in that 0 and got 1 over 25. That's not the problem. Where is the problem? Here is the problem. And I guarantee you somebody in here was like, what the hell? What is he doing? I guarantee you somebody said that. You don't have to raise your hand. Your algebra is what? Rusty. I got a common denominator. If right here, I got a common denominator right there. Now, I could have done all that in one step, couldn't I? Yes. I could have got a common denominator and converted the numerator also, the denominator, and got rid of all this and done it all at one time. I could have done that, but I didn't. So I got the new numerator, and there's the new numerator, negative h over 5 times 5 plus h. And then I put it over h over 1, multiplied by 1 over h, and the h is canceled. That left me with this. And then you just plug in 0. I have found that the problems that students have is when they have a fraction and they have something in the bottom, and that's where they go crazy with the limits. They don't know what to do. And therefore, you have to rely on your old algebra skills. So therefore, if you suck at algebra, you're going to suck at limits. I'm just going to put negative 1 over 25, but they probably want all that. I'm not going to write all that. So I'm just going to hit answer. They want this. Now they want negative 1 over 25. That's a good test question. If I give you a test, I mean probably on the Unit 2 test, or I might give you a Unit 1 test that just has about 10 limits on it. Unless y'all want 25 or 30.
No, thank you.
Okay, I got one person reacted. That's good. Thank you. That's another one. Let's see if I can find. Okay, what do you do in this case? Well, I'd get rid of the denominator or do something with that denominator because you can't do it. Maybe the conjugate? I don't know. If you do the conjugate, you get x squared minus a BA number. No. Maybe rewrite the radical. We'll get back to that one. I want to get to a conjugate that I recognize. Let's get to, there we go. All right, what's wrong with this one? Well, you're going to get a 0 in the denominator, which 0 gives you, if you was to, 0 gives you the vertical asymptote. I understand that, but you're not trying to find the asymptote. They're asking you for the what? The limit. So do that one using the conjugate. I'll write it on the board for those that's going to complain. I can't say it. I can't say it. Help if you didn't sit in the back of the dadgum room. Limit as x approaches 38 of x minus 38 over square root of x minus the square root of 38. All right, I'm going to let y'all take off. See what you get. What time did you say class was over? 4:10.
4:25.
I'm not assigning any homework yet because I haven't finished going through the homework. I'm just pulling out some problems. This is not your homework. This is like they call the study. This is extra problems. I'm going to go through and take out a lot of the homework in chapter 2. We're not going to spend a whole week and a half, 2 weeks on a concept. Let me ask you a question, Pendleton, and there's only one person at Easley. Pendleton, as far as there's 5 people there, in your past, how have you learned, limits? Has it been a problem? Have you never had a problem with it? Or tell me, just roundabout. Ms. Gusmus, we'll start with you.
What do you mean a problem?
In the past, like with other maths, like with college algebra or with in a calculus that you've had before, have you ever had any trouble with limits?
No.
You never had them before, or what?
Have.
Did you have any problems with them?
No.
Okay. How about the rest of you at Pendleton?
I've
I had
never
a good
dealt with
teacher,
limits
so they
before.
came pretty easy.
Say it one more time, Pendleton.
I had a good teacher, so they came pretty easily.
Okay. What about the other three guys?
I've never had them.
Never had them?
Not that I remember, anyways.
Okay. What about the other two guys?
I never had a problem.
I've never had a problem.
Okay. How about easily? You only got one person up there at easily. Miss Sterling?
I've never dealt with limits before.
You never dealt with them? Okay. How about our Polycom people?
I've always been bad at limits. Like,
You've always
I never
been
had a
bad?
good teacher to help me understand them. So with the couple of different times that I've seen them, they've been explained differently, and they've just never made sense. So.
Okay, well, hopefully me just taking a direct approach and talking about the difference in the concepts and then the emphasis on the algebra, hopefully you'll at least get these two parts, because I'm going to be honest with you, there's not really a lot of places for all this limits. It's not really compatible with learning at least the first trig, at least the first calculus. But what about the rest of you polycoms? Y'all okay with limits, or you ever had a problem with them? Never seen them?
It was pretty easy for me, but like I said, I mean, you just have to work through them.
Okay, how about the rest of the five?
I had it before. I think it's a lot of practice you need, because there's just so many different approaches you have to take it to break it down.
Okay, anybody else want to throw out anything?
When I took my SAT scores, they pretty much said, oh, you scored decently high in math. You don't need to take any college math the entire time you're in college. And then when I decided to take engineering, I was like, oh, I'm fucked.
Yeah,
Great.
exactly, because that, they people in high school and counselors, they don't want you to take too much math while you're in high school, because, they want you to go ahead and get by and graduate. Because if you take too many maths and sciences, you might fail, and you mess up their money numbers. So that's why you get a lot of people. I mean, we're told, oh, you just need probability your senior year. Yeah, that's why.
They had me take a engineering course last semester that dealt with physics math, and I don't take physics until the fall.
Yeah.
I'm doing a lot of catching up in math.
Well, I just wanted to ask, because I know in past in a lot of calculuses I teach, whether it's business calculus or whether, you've got to explain limits, but you don't have to spend a whole month on it. You don't have to spend a whole 3 weeks on it.
In business calc,
Yeah.
we didn't actually work out any of these. All of this is straight calculated.
Yeah. Well, see, that's that. You've got to understand, because
So limits were easy. But
yeah,
it was the
yeah, because you just did it on the calculator.
Skipped all over the algebra wasn't even touched on.
Conjugate, square root of x plus 38. So therefore, in the denominator, we're going to get what? X minus what? And the top, we're going to get x minus 38 times square root of x plus square root of 38. Now what happens?
X minus 38's cancel.
X minus 38's cancel. And now you're left with just a regular limit. As x approaches 38, what is my y going to approach? Well, what's square root of 38? I'm sorry. I thought that was a minus. So somebody take square root of 38, multiply it by 2, or add the square root of 38 to it. Somebody do that for me. 2 times square root of 38.
12.
I want you to do the calculator. What?
12.33.
So your y, if everybody got 12.33, that's you're approaching, when x is approaching 38, your y is approaching 12.33. And that's what you're doing. You're basically finding when x is approaching a number, what is y approaching?
Where did you get 2 root 38? How did you pull out of the root?
Well, 38 goes right here. What's the square root of 38 plus square root of 38? There's a 1 here and a 1 here. What's 1 plus 1? 2. When you're doing radicals, you can add radicals. If there was a 2 here, 2 square root of the x plus 2 square root, well, that's 38. You plug 38 in. That'd be 38. So 2 plus.
Oh, I'm sorry.
Yeah, you got to plug it in.
Okay, that's okay.
Yeah. All right. So I'm not going to answer the first part because that's punching a bunch of stuff in. I'm not going to do that. So we'll just say square root. Yeah. Check answer. Okay. And then we got, now they say type an exact. What does exact mean? With the radical. So that'd be 2 square root 38. And you feel good about yourself. Question, gripe, complaint. There's another one. We got to do something. Well, the first thing I would do, I would rewrite that. I'm not going to do this one, but I would rewrite that square root. I would rewrite it. This might be an example of you using the conjugate on the numerator. So that would be a hint there. Because you got a radical in the numerator, you need to get rid of it. Because you can't do anything, you can't get blood out of a turnip. Is there anything you can do with H to change it? No. You can't change it. Well, you can multiply it by 6. Well, what's 6 times 0?
0.
You can divide it by 2. What's 0 divided by 2? There's nothing you can do down here to fix it. So you're going to have to focus on the numerator. Another rule. When you can't fix the denominator, you have to focus on the what? The numerator. So we'll do one like that later, not as introductory. We're going to do that one later. See if I can find another one. I want to find another complex, but I don't know if they have one or not. This one, when in doubt, factor it out. Why? How do you know that? Well, you got a trinomial up top. And then you got a cluster on the bottom that you can factor out a W or a W, depending on where you're from. So you're going to use the reverse FOIL on top, and you're going to factor out a common factor on the bottom. And something's going to cancel out. We're not going to do that. One's pretty simple. I just want to see what other kinds we got. Conjugate. You're going to multiply the top and the bottom by the square root of 7x plus 15 plus 6. So let's do that one. I'll write it on the... So limit as x approaches 3 of x minus 3 over the square root of 7x plus 15 minus 6. All right, I'm going to let y'all work on it for a couple of minutes. I'm going to go ahead and call the roll while y'all are working. So that way y'all can, like, bat out of Hades, run out of the classroom. Mayberry Community College. Log out after 15 minutes. Where do you clear the cookies? Thought it was under settings or history. There we go. Thought you could clear out.
I think it's more tools.
Thank you. Clear browsing data.
Mm-hmm.
There we go. Thank you.
Yeah, that's it.
Thank you.
Or Control Shift Delete.
Thank you.
You could try turning it off and turning it on again.
What'd you say? Control what? Shift delete?
Well, Control Shift Delete. That's going to take you to what you just had. I'm just telling you that's a quicker way to get there.
Well, why isn't it doing it?
Is it open in another tab as well?
I don't know. I don't think so. No. Oh, Lord. Mayberry Community College. We're behind 10 years in technology. And we go to conferences about putting posters up in the classroom.
I have an answer when you get done with that.
Well, heck, I can't even get to the dadgum. And if you don't turn in the attendance, you got some little, oh my God. You got some little person over in the library that has a job because of the attendance. You missed your class. You missed turning in attendance. Okay, forget it.
Everybody here? Yeah, we're here.
Thank you. I'm just going to put everybody here today. Stupid. Having to take attendance in college. Okay, let me get back to the question if I can get back to it. Heck, I can't even pull up the email. No, it's not email. It's there we go. All right, so I'm going to multiply through by the square root of 7x plus 15 minus 6, which is going to give us x minus 3 times the square root of 7x plus 15 minus 6 over, well, that's going to be 7x plus 15 minus what? 36, right? Somebody check my algebra in the denominator. Isn't that right?
You're good.
Okay, thank you, one person out of 19. All right, so x minus 3 times 7x plus 15 minus 6 over 7x minus what? What's 5 minus 36? Negative 31?
20.
Y'all check me. It should be negative 31. Now plug in 3. Well, 3 minus 3 is 0. I'll do the top for you. 0. And then what's 3 times 21 divided by, it doesn't matter. What's 0 divided by a negative number? 0, Hubert. Thank you, class.
Shouldn't it be 7x plus 15?
Yes, it should be.
Thank you. Still, it doesn't matter because this takes it out. What? 15 minus 36 is what? Negative 11?
Negative 21.
Okay,
so
whatever.
then the x minus 3 cancels out.
Yeah, the x minus 3 is going to zero out everything. Right?
No, it'll be 1 over 1, right? So then you'll have 7 on the bottom.
Okay, let me go back. Okay, I'm sorry. I suck. So that'd be 7x minus 21. Okay, the 7's cancel. The 7 comes out. X minus 3, they cancel. So you're left with square root of 7x plus 15 minus 6 over 7, and then plug the 3 in. That'd be 21 plus, that'd be 36, that'd be 0. It still comes out to be 0, doesn't it?
Yeah, because it's supposed to be plus 6 on top, not minus 6.
Dadgummit, did I
So
make
it'd be 12 over 7 as your
Oh, thank you. 12 over 7. That means it's time to quit. Now, of course, if I don't do the attendance today, all of you are going to get a grandma note in your email that says that you've missed class. And then all of you are going to write me an email that says, it says I missed class and I came to class today. When you get an email like that, just ignore it. For my class, just ignore it. That means I forgot to do the attendance. And the little mouse over in the office, in the corner office, the closet office that does the attendance letters, is sending you a letter that says that so he can have a job. Okay, so again, we're just scratching the surface on this. Thank you for correcting my mistake. I'm sorry. That's what happens when you skip steps. Let me hit this two or three times and so y'all can see. There we go. And then 12 over 7. That's a good question to write down. So far you got what? How many questions did we do? 4 or 5? Look in your notes and count.
5.
5? So we'll do another 5 or 6 when y'all come back over the weekend. I want you to work on homework in the weekend, over the homework and tests, get all that out of the way so we can get on to chapter 3, okay? Y'all have a good day, and I'll see y'all when I see y'all. Tuesday, Monday, the rest of the day. Oh, today's Thursday, isn't it? Yeah. Oh, so I'll see y'all Monday.
Mr. McClure.